So this video is about making the connection to all the Riemann sum stuff we've been doing to the actual main topic of this class, which is integration. So this little symbol here, you're going to get really used to this. That's the integration symbol. It's actually just a giant stretched out S because it's just like this sigma is the Greek letter for S. This is also an S to remind us that we're a sum. So if you hear nothing else today, or if you learn nothing else from this class, the one thing you need to understand is an integral. That's this little symbol here. Oops, I guess you can't see where I'm pointing. This little symbol here stands for summing things up. So that means that it essentially is going to add a bunch of little things up. That's whenever you see that symbol, you want to think about what is it that I'm adding up. And so the connection we want to make is to sigma notation, because obviously that's also adding things up. So we've been playing around with this right here, this sigma notation with the number of rectangles running to infinity. You can tell this is the width of the rectangle. This is the height of the rectangle. And so what I want to establish today, or make the connection today, is that this expression right here, this sigma notation with a limit, is the same thing, produces the same result as this symbol over here. Okay? So, and notice the things that match up in the way we find our width of a rectangle is b minus a over n. And notice these are what are called the limits of integration. You got the b on top and the a on the bottom. So this is the left side of the a is the left side of the interval that we're dealing with, and b is the right side of the interval we're dealing with. And this is not maybe not abundantly apparent, but this part right here becomes that, because what we're talking about is a small change in x, and the function that we're using here is the function that we integrate over. So that's the connection. I'm going to show you an even deeper connection here, how it works. So let me hop over to here. So we've been doing some playing around with Riemann sums, and basically the idea is we can approximate the area under the curve by showing a rectangle. So this right here is one rectangle that's approximating the area under the curve from A to B. Of course, it's not a very good approximation because it's just one big rectangle, but if we were to change this to two rectangles, you can see it gets a little bit better. If we change it to 3 rectangles, 4 rectangles, 5 rectangles, 6 rectangles, and as we do that, we see the extra space, either the space under the curve that's not covered orange, or the space outside the curve that's colored orange. This would be under stuff we're not accounting that we should, and this would be stuff that we this is stuff that we are not counting that we should. This is stuff that we are counting that we shouldn't. So that's why we know this is, it makes it very clear it's an estimate. It's approximation. So, and actually, as notice down here is that little symbol we were just talking about. This is telling you the actual area under the curve. So you can see how far away it is right now. Right now, with these 6 left-hand Riemann sums, we have 10.819, and the actual area under the curve is 11.497. So now let's see what happens as we go up by one rectangle at a time. So notice as we add one rectangle, the rectangles are getting smaller, of course, and the approximation is getting better. Notice also, watch this orange number here. It's getting closer and closer to this black number. We're at 29 now, 30. It's getting closer, it's getting closer. I'd have to stop it here. I think I can stop it. It's getting really close. And look at that, we're only halfway. This is going to take it all the way to 80 rectangles. We're just barely over halfway, and we're getting really, really close. We're already in the 0.4 range. Oh my goodness, look at it closing. And you can see that itsy bitsy little overestimate there, and you can see the barely see the underestimate there. Okay, let's go by tens now. You can see it happen even faster. Whoops, I went right past it. When I get close, I'll go by one, so it slows down. Ah, start over. Let's just go to 70. So there we are at 79. You can see, and it's still an estimate. I mean, it's not exact. We're getting a lot closer. I wonder, I don't know if I can put in a higher number than 80. I'm going to try it here. What if I do like 200? Will it break the system? I don't know. Look at that. It's still, and notice the sum is still not exactly right, but they're so small and blurred together we can't even see the rectangles anymore. But you can see that it's still an estimate. Even though we got 200 rectangles, it's still an estimate. So in order to get the actual area under the curve, that's why we need this limit process, that we're going to let the number of rectangles approach infinity. But the point that you just saw, that it does, the right-hand sum gets closer. Okay, let's start over again and go back down to, say, 2. And let's show a right-hand rectangle. That was the left-hand before, right? So again, it doesn't really matter if it's right or left, because you can see even if it's right, it's also going to get closer and closer and closer. Or if we go to a midpoint, there's the midpoint. Let's let those get closer. And again, you can see that the midpoint sum is getting closer and closer to the actual area. So it really doesn't matter which Riemann sum we choose, right, left, midpoint, or some other, as long as we're allowing the number of rectangles to approach infinity. It's going to approach the actual right area, and if we take the limit, then we find out what it's approaching, which is the exact area. But the main point you want to get out of this little discussion is that, I should hide that, is that instead of having to do these Riemann sums all the time, we have this new process, this little symbol here. So, and I'm going to talk about what that symbol means. Okay, so we're going to exit out of this and go back to this. So what is this symbol? Now, a lot of you have had some previous experience with calculus, so you may already know, but this symbol, besides meaning I'm adding up a bunch of little things, it also is the way we deal with it is the antiderivative. And the next video is going to talk about the fundamental theorem of calculus, which explains that very topic. But basically, when you see this, you're undoing a derivative. All right.